section 12.6, surface area and volume of spheres. Surface area of a sphere is going to be equal to 4 times pi times the radius squared. Here we're given a sphere with the radius of 4, so we plug that in. We've got 4 times pi times 4 squared. We know 4 squared is 16. 16 times 4 is going to give us 64, so we get 64 pi, which is approximately 201.062. A great circle of any sphere is just a circle going around that sphere. It's any really cross section there would be similar to our our equator would be a great circle of the Earth, which is a sphere. The prime meridian, any one of those latitudinal longitudinal lines would be a great circle. The circumference of a great circle is 13.8 pi. What is the surface area of that sphere? So we know a circumference is always going to be equal to 2 times pi times a radius. We need the radius to find the surface area. So we can set our 13.8 pi for the circumference equal to 2 pi r, solve for r. R is going to end up equaling 6.9. We plug that in then to our surface area formula, so we'll have 4 times pi times 6.9 squared. That's going to be approximately 190.44 pi, which is approximately 598. Here we're asked to find the surface area of a sphere if the area of the great circle is approximately 220 square meters. So we know area of a circle is going to be pi r squared, so we set our 220 equal to pi r squared, divide both sides by pi, take the square root. Our radius is going to be approximately 8.4. We plug that radius then into our surface area formula, so we got 4 times pi times 8.4 squared. So when we plug that in, we're going to get approximately 886.7, and that's going to be meters squared. Here we're asked to find the surface area of a hemisphere, given the radius of 3.7 millimeters. We know that a hemisphere is half of the sphere, so we can start out by taking half of the surface area of the sphere, but the surface area of the sphere doesn't account for the circle that's making up the base of our hemisphere there, so we need to add that along with it. So we start with our 1/2 times 4 times pi times the radius squared for the surface area, but then we also add on the area of that circle, which would be pi r squared. So then we just plug in our radius in here, our 3.7. So we know 1/2 of 4 is going to be 2, so we'll have 2 pi times 3.7 squared plus pi times 3.7 squared. When we multiply all that out, we're going to end up getting a surface area of 129 millimeters squared. Alright, in this next problem we're asked to find the surface area of a sphere given the circumference of a great circle being equal to 8 pi feet. So we take our 8 pi, we're told that it's the circumference, so we set that equal to 2 times pi times our radius, divide both sides by 2 pi. If we look, our pi's here will cancel out. We know 8 divided by 2 then is just 4, so our radius is going to equal 4. Like earlier we solved a problem with the radius of 4, so we know that's going to end up being, well, if we plug it in, we've got 4 times pi times 4 squared is 16. 16 times pi is, or 16 times 4 is 64. 64 pi is going to be approximately 201.1 feet squared. Here we're asked to find the surface area of a hemisphere. So we just plug that into our formula. We know a hemisphere is half a sphere, so we've got 1/2 of 4 times pi times 4.2 squared. But then since it's a hemisphere, we know we have to add on that bottom surface of the circle, so we add on the area of a circle. So we add on pi times our radius, which is 4.2, and we square that. When we multiply those out, we're going to get approximately 166.3 meters squared. In this problem, we're asked to find the surface area of the given sphere, rounded to the nearest tenth. Right here, we're given that the radius is 6.25, because we know the radius of a sphere is from the center to any outside edge of that sphere. So it doesn't matter if it goes straight across towards that great circle or if it goes up or down, left or right. Here it goes at an angle, but either way they tell us it's 6.25. So we just plug that in. We've got 4 times pi times 6.25 squared. Pop that into our calculators, and we get out approximately 490.9 inches squared. Here again, surface area, given that a great circle's area is 160. So we set our 160 equal to area, which is pi r squared. We want to solve for the radius. We divide both sides by pi, so we got 160 pi equal to r squared. To get it equal to r, we square root both sides. So we know the square root of 160 over pi is going to equal our radius. We plug that into our surface area formula because we want surface area. We know surface area equals 4 times pi times our radius squared. So we've got the square root of 160 over pi squared. We know when we square a square root, those will cancel out. So our surface area is going to equal 4 pi times 160 over pi. If we look here, our pi's cancel out. We're left with just 4 times 160. 4 times 160, we all know, is 640 feet squared. Moving on then to volume. The volume of a sphere is going to be 4/3 pi r cubed. Since we're cubing the radius, our units now go to units cubed. So if we have meters, it's meters cubed, inches, inches cubed, etc. So here we're asked to find the volume of a sphere with a radius of 8. So we can go 4/3 times pi times 8 to the third power. We plug all of that in. Again, remember, we want 4 divided by 3, not 4 divided by 3 times pi times 8 cubed. So we put our 4/3 in parentheses. And we multiply by pi and by 8 to the third. We get out 2,144.7 centimeters squared. Here we're asked to find the volume of a hemisphere with a diameter of 6. If the diameter is 6, we know the radius is then going to be equal to 3. The one nice thing about volume compared to surface area with a sphere, the hemisphere doesn't change volume, since the hemisphere has that extra base of a circle, that doesn't really change the volume much. It's still just half of the whole sphere for our volume. So we just take half of our volume of sphere's formula. So we've got 1/2 times 4/3 pi r cubed. We plug in our radius. We know our radius is 3, and we know half of 4/3 is really 2/3. So we're going to end up with 2/3 times pi times 3 to the third. We know 3 to the third is 27. 27 times 2 over 3 is going to be approximately 18 pi. 18 times pi is about 56.5. So 56.5 feet cubed, or cubic feet, as they word it here. Again, because the radius is the third power, our units need to be the third power. Here we're asked to find the volume of a hemisphere with a diameter of 80 meters. So we just take our 4/3 times pi times our radius, which would be 40, to the third power. And we want half of that because we have a hemisphere. So instead of plugging it into our calculator like this, we know half of 4/3 is just 2/3. So we get 2/3 times pi times 40 to the third power, which is going to be approximately 134.041.3 meters cubed. Alright, volume of sphere we know already, 4/3 pi r cubed. If we're asked to find the volume of this figure, we look, the red is indicating that those two hemispheres are going inward. They're not filling up any space, so we don't just have the volume of a cylinder here. We've got a cylinder with two kind of tops pushed in. So we know the volume of that cylinder minus the volume of the sphere is going to give us the volume of this figure. So to find the volume of our cylinder, we're just going to take pi times our radius squared times the height, and then we're going to subtract off the volume of our sphere, which is just going to be 4/3 pi r to the third, or 4/3 pi r cubed. We know it's a full sphere because we have two hemispheres that are being pushed in. So if we multiplied half for our hemisphere, then multiplied by 2, because there's two of them, we'd get our full sphere formula. We plug in 5 for our radius, 12 for our height. Pop that into our calculators, and we're going to get approximately 418.879 units cubed for our volume. For tomorrow, we have a blog due. You're already in possession of your homework checks, so start working on those. Have a fantastic night.